Good afternoon, everyone. Myself, Mrs. Charushila Rane, working as an assistant professor at Rajarshi Shahu College of Engineering, Tathode. In this session, I will be discussing some of the properties of the DFT, that is discrete Fourier transform. So the title of experiment is write a program to study and verify DFT properties. The formula for DFT calculation is given like this. The time domain sequence x of n becomes x of k after transformation in discrete Fourier domain. The formula is it becomes x of k, and the formula for x of k is summation of x of n into e raised to minus j to pi I upon n into kn, and the n is varying from 0 to n minus 1. N is the length of sequence. So k is varying from 0 to n minus 1. So if you want to apply that formula for DFT calculation, then here one example is solved for DFT calculation, where the sequence x of n is given as 1, minus 1, 2, and minus 2. Since it is having total 4 number of elements, the capital N value is equal to 4. So x of a can be calculated with the formula, whatever already we discussed. So in that calculation of DFT, we can substitute the values. Here the x of n sequence multiplied with the Twiddle matrix. The values of sequence x of n are given as 1, minus 1, 2, and minus 2. So by this multiplication matrix method, we will get the answer for this DFT calculation like this. First element is 0, second element is minus 1 minus j, third element is 6, and fourth element is minus 1 plus j. So whatever is the length of sequence x of n, same will be the length of DFT calculation. Now same numerical we will solve with the help of MATLAB program. So first of all, we will see what are the statements or what are the instructions we need to calculate the DFT. As usual, these common instructions CLC and clear all will be given as initial lines. Then through the keyboard, we will accept the input sequence and that will be stored in the variable x. Next statement, n is equal to length x, will count the number of elements in inputted signal. Then as per this formula, the exponential term is calculated separately in this for loop. Here the two variables k and n are varying in their values. K is varying from 0 to n minus 1, n is also varying from 0 to n minus 1. So here we will see the for loops, two for loops, and there we are calculating the exponential term. Then since we have started the n variable from 1 instead of 0, here we have subtracted 1 from both the variables k as well as n. So at the end of this for loop, we will be having the calculation of this exponential term, and that should be multiplied with the input sequence x. So total DFT output y is nothing but x multiplied with this exponential term calculation. So in y, we will get the DFT result. Now same program we will execute in MATLAB and we will observe the result. Here we can see through the keyboard, input sequence is accepted, length of that input sequence is calculated and stored in variable n. The exponential term is calculated in this for loop. Then out of the for loop, DFT resultant is calculated and stored in variable y. The y values are displayed. See the execution of this particular DFT calculation. The same mathematical equation or same sequence we will apply as an input. It is 1 minus 1, 2 minus 2. 1 minus 1, 2 minus 2 is the input sequence, and this code will calculate the DFT of inputted sequence. We can see the result. It is having the 4 elements, and these 4 elements are matching with our theoretical calculation. First element is 0, second element is minus 1, real part minus 1, imaginary part is minus I, third element is 6, fourth element is minus 1 plus I or plus J. So the answer is matching with our theoretical calculation. That is about the DFT calculation. Then some of the properties of DFT we will discuss. The property related to circular time shifting of the sequence. So whatever is your x of n sequence, if you are applying the shift of amount n naught to that sequence, then the equation becomes x of n minus n naught. So if the DFT of original sequence x of n is x of k, then DFT of the circularly shifted sequence x of n minus n naught will be like this: x of k multiplied with the term e raised to minus j phi n naught k upon capital N. So the shift amount n naught is reflected here on the right hand side. So original DFT is getting multiplied with the exponential term. So in this exponential term, real component is 1. That's why in the graph we will observe that the real part of the graph of x of k will not change, magnitude will not change, its phase is getting affected. So this particularly circular time shifting of a sequence property we will observe in MATLAB software. As a first line, we will give the title of our property. Then these three instructions are common in all the codes: CLC, clear all, close all. Then the input sequence X is entered directly. Then in the next line, length of the inputted sequence X is calculated and stored in the variable capital N. Then the shift amount is declared here in variable M. It is equal to 5. If the shift amount is greater than the length of the sequence, input sequence, then some adjustment we have to do over here. So in this loop, if the amount of shift is greater than the length of X, then remainder of division between shift amount and the length of sequence X is considered. And if M is given negative, then also the adjustment is done like this: M is adjusted as M plus length of X. Then whatever is the amount of shift, as per that, the given inputted sequence X is shifted, and shifted sequence is stored in Y. On the next line, number 16 and 17, DFT of original sequence and DFT of shifted sequence is calculated, and the respective outputs are stored in XF and FIF variables. By using subplot instruction, the figure window is divided, and there the plot of absolute value of XF means magnitude plot of XF as well as magnitude plot of YF is indicated. Again, after DFT calculation, if we are taking absolute value of XF, we will get the magnitude plot. If we are taking angle of XF, we will get the phase plot. So in the next part, one more figure window is generated. Again, that figure window is divided in two subsections, and in these two subsections, the phase of original signal as well as the phase of shifted signal is plotted, and the effect on amplitude or magnitude as well as on phase is observed. Now we will run this code. we can see the original signal X is available here and Y represents the shifted signal. Since the shift amount is given as 5, we can see that the original signal is shifted by 5 elements. So Y represents shifted signal. And now we will observe the figure window. First figure window gives the magnitude plot of original signal as well as the magnitude plot of circularly shifted signal. So there is no change in the magnitude plot because as per the shifting property, if the signal is shifted, circularly shifted in time domain, in DFT domain, the original DFT is getting multiplied by the exponential term. That's why there is no effect on the magnitude plot. Now we will see the second figure window, which contains the phase plot of original signal as well as the phase plot of circularly DFT of circularly shifted signal. So we can see the DFT, we can see the phase plot of DFT of circularly shifted signal is changed because of the property statement, as per the property statement. So that is all about the time shifting property. One more property related to DFT we will discuss, and that is a Percival's theorem. As per Percival's theorem, if the DFT of first time domain sequence x1n is x1k and DFT of the sequence x2n is x2k, then summation of x1 multiplied with complex conjugate of x2n is equal to 1 by n summation of x1k multiplied with conjugate of x2k, and the summation is taken for the range k is equal to 0 to n minus 1. So now, as per this Percival's theorem statement, we can say that DFT is an energy conserving transformation. Means even though we are transforming from time domain to frequency domain, energy conservation is shown. DFT allows us to find the signal energy in either form, means from the signal itself or from its spectrum. So here on the left hand side, whatever is the term, that is the energy calculation in time domain, and on the right hand side the calculation is for energy in the DFT domain, frequency domain. This implies that the sum of squares of the signal samples is related to the sum of squares of the magnitude of the DFT samples. So this particular statement shows the energy calculation from signal itself or from DFT samples. So in MATLAB, if you want to verify this Percival's theorem, then we have to give the statements like this: CLC clear all close on. Then one signal sequence is declared here and stored in variable X. So it is the signal X is nothing but the numbers change starting from 1 ending at 128 with the step size of 1, and then next to that the sequence is cascaded, which is starting from 128 and ending at 1 with the difference of -1 every time. So X will be 1, 2, 3 up to 128, then again 128 to 128, 127, 126, likewise up to 1. So this is a sequence X which is having total length of 128 plus 128. Then in Y variable, the DFT coefficients, DFT samples of X are stored. So FFT instruction is used to calculate DFT of the time domain sequence. Now, now we are having the sequence in time domain as well as its DFT samples. So as per the Percival's theorem, we can calculate the energy from X also as well as from Y also. So here in Y1, sum of X into X is calculated, which is the energy calculation in time domain. And that Y1 value is displayed here along with the label energy in time domain display the value whatever is in y1. So y1 contains the energy calculation from time domain signal. Then in the variable y2, length of given sequence x is stored because we need the total number of elements while calculating the energy from DFT coefficients. Then absolute value of this DFT coefficients y is taken stored in y3. Then as per the formula previously we have seen, the energy is calculated in y4 variable. So y4 is equal to summation of y3 into y3 and divided by the length of given sequence, means how many elements are there in the DFT sequence. So that parameter is considered here in denominator. So now y4 contains the energy calculation which is done from DFT samples. Then to verify the accuracy of time domain calculation with the energy with the frequency domain calculation, difference between these two values is calculated, and that difference is stored in variable y5. So y1, which is the energy from time domain sequence, and y4, which is the energy calculated from DFT coefficients. So the difference between these two parameters is checked, and that is stored in y5, and that is referred as error. So with the title error, this y5 value is displayed, as well as energy in frequency domain is also displayed, which is stored in variable y4. The same code we will execute in the MATLAB software. You can see same code is saved here in the MATLAB version 2020. The sequence X is given, then DFT of sequence X is calculated, stored in Y, then energy values are calculated in time domain as well as in frequency domain. Error between these two results is calculated and all the values are displayed. Now we will run this code. So for the given sequence X, we can see that energy calculation in time domain is exactly matching with the energy calculation from the DFT samples. Error is 0. So here we can say that Percival's theorem is proved. Thank you.